the difference is 1,000 or more between the concentration and your K value. So now this is question 21. Okay. What elements that are exceptions to electron configuration? You know what? Let's actually look at our periodic table. I think I'm starting to understand the ones that are exceptions. So, with that being said, actually, if you look at column 6, okay, because as you remember, that one was Chromium, and that's the one that had the so exceptions to electron configuration. Okay, and for this one, I'm going to be honest, I'm only familiar with the ones in the D shell. I'm not really sure how the F shell works. We don't really seem to touch that from what I remember being taught. With the exceptions, Chromium, right? Remember when we started from the argon? Okay, it was 3D54S1, exact, because it was one away. 1, 2, 3, 4. Okay, it used to be 3D4. So you can tell anything actually in the 6th column. So that includes molybdenum, tungsten, and seaborgium, most likely. That would be your so column 6 would be your first exceptions. And now same thing, you go over to column 11, right? And remember, copper was AR 3D10 4S1 because of just one change, just to be able to get that shell full. So it'll be column 11. Elements from column 11 as well would be exception to electron configuration. Those are the only two that I'm familiar with. If they include the for the Ruthenium series and Actinium series, I would assume that it's going to be 1 before 7. So 1, 2, 3, 4, 5, 6, 7. Nope, sorry, I counted wrong. 2, 4, 5, 6, 7. So it'll be like maybe europium and americium, and maybe terbium and nobelium, I'm assuming. But I don't want to say those yet because let's just see what they say. So the elements are exceptions to the electron configuration. Rules are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's see what they have to say. So copper, silver, gold, and they also said chromium, copper. What's niobium? Oh, I don't know why that's included. Molybdenum. Yep, that one makes sense because it's part of that list. And then ruthenium. Where's ruthenium? There it is. I can't say why ruthenium is there. I'm gonna be real honest with you, because yeah, I can't say why it's there. Rhodium, that one also I can't say. Palladium, yeah, I can't say for that one either. Silver, yeah, that one makes sense because it's so close. Platinum, where's platinum? Right here. And gold. Interesting. I still think it's going to be mostly column 6 and column 11 based on how they broke down for the electron shell. But I may be completely wrong when it comes to that. Let's see. Some atoms, such as transition metals, and some elements in the lanthanide and actinide series do not adhere to Hund's rule, which is fair. Hund's rule states that every orbital must be singly occupied before any orbital is doubly occupied, while Pauli's principle is that no two electrons can have the same 4 electronic quantum numbers. Yeah, exactly. Using the figure above, the supported electric configuration of these rules are followed, and the actual electric configuration for these elements are shown. So chromium, yep, that's what we did. That one makes sense. Copper, yep, makes sense as well. While I would prefer the order to be changed for it to be 3D10 then 4S1. Niobium, 5S2 4D3. See, this one makes more sense because the d orbital is half filled, but it just says like, oh yeah, this one, the closer it gets, the more stable it will be. Same thing with this one. The closer the d orbital gets filled, the more stable. Same with that. And palladium literally does what we discussed that shouldn't happen. We just got rid of the whole orbital, because we tried that and said it was wrong. So this one I'm having a bit of an issue agreeing with or not. They are called exceptions for a reason. Silver, exactly, that one makes sense as we discussed because it only needs to fill in one more. Platinum, the F14 part doesn't really matter, but exactly, like that one, it doesn't make sense. Why would they not just do 2 like the other one? Gold, yeah, that one makes sense because it only needs one more. Let me see, yeah, because platinum I don't really understand why. In fact, what I'm going to do here is search up electron configuration platinum. Yeah, I can't tell you why. So this is correct. That's great. So I guess this just boils down to just memorizing it. There seems to be no real concrete way of saying whether or not it would prefer a certain type of configuration. But I'll definitely look out for the ones, at least for me, the ones on column 6 and column 11 at least will set off alarms to say, okay, I need to be careful on how I navigate it. The rest of them, I guess, is kind of to your discretion, really. Let's move on to question 22.